Hello, this is Paul from Foresight Tech. In this lecture, I will going to introduce trig integrals. Okay, we're going to build the strategies or experience for trig integrals. We have different types. The first type is the powers of sine and cosine. Can we see? The power sine, the power of cosine times together the product. We do this type first. Here's a summary. So we have three cases for this one. Depends on the power m and n. Okay. So different type we do different substitutions. So we look at the first. If n or the power of cosine is odd, we will do substitution for this for sine. Okay, u equals sine. If the power of cosine is odd, we substitute the sine. The opposite. If the power of sine is odd, we do substitute the u equals cosine, which is the opposite. Okay, so keep in mind. If we cannot see any odd power, both are even, how to do? We still have a strategy. We can use the half angle or power reducing. Okay, identity we learned from trigonometry. Okay, to reduce the power. After reduce, you will find so either one is odd. If not, we can reduce again. Okay. So for the first two is the major. So we're going to see I have two small examples to show you the basic ideas how to set up, and then later I have a complete example to show you how to do. So for the first, can we see which one is odd? Okay. And the power here is odd. Okay. The other power is for cosine. So for cosine, so we have to do substitution for sine. How to make it ready for your substitution for sine? Okay, remember if you do this substitution, du equals what? Cosine x dx. What it means, we have to separate the one cosine x. Okay, link with dx, right? I show you here. So I wrote to make it ready for the substitution, separate the cosine. And then what do we have? Our cosine is odd, and then cosine times dx. Separate the cosine. After we separate the, see what do we have? We will have this. Okay, sine first power, cosine the second power, and the times cosine x dx. Remember the substitution? Can you see? If we substitute the u equals, these are the substitute the sine. Substitute the sine. See what do we have? Can you see why we separate? Because this goes to what? Goes to du. Okay, it's easy. So this goes to u raised to the fourth. How about the cosine square? We have a little trouble, but it's okay. We have a Pythagorean, right? So we can make a cosine go to sine. So we can make a u. Can we see if I put it here? So it's a Pythagorean we need to use. So make a cosine to sine. After we use Pythagorean, now you can see what do we get. Okay, this is u raised to the fourth. This is 1 minus u squared. All these put together is a polynomial function. Is a power function. Is a power function of u. How about this? Du, right? So put it here as du. Can you see this? Much easier. Okay, so this is very easy because this integrand is a polynomial. Image means the sum or difference of the power, the linear combination of power. Okay, so good. I did the first, and then can we look at this? Similar, very similar. Okay, so here is all the idea. All we need to do is just like this. Similar, very similar. Look at which is odd. This is odd. If this is odd, later we do substitution for cosine. This, see, you imagine if we do substitution for cosine, what do you mean? Okay, so it means du equals negative sine x dx. We need to separate the one sine, merge with dx together, make it ready for substitution. So I put it here again. Separate one sine, keep in mind the other separate the one, this, and then I should do this. After we separate it, now we have what? We have a sine second power, right? Good. and the times we have another 1 separate 1 sine goes to here, and the dx. Why we do this? Because you know we need to do this substitution, right? Substitution u equals cosine. If we do this substitution, you know what this. Now this is a negative, right? du, okay? At least this goes to du. Negative 1 times du is okay. So how about the cosine raised to the fourth is u raised to the fourth. Now have only 1. When we need to do substitution, this should be goes to cosine, right? This how it goes to cosine the same. Pythagorean, okay? So up here is a Pythagorean. All we need is that, and then if we look at what do we get? This is 1 minus u squared times u raised to the fourth, which means the integral goes to polynomial again, and then this goes to du. See, this is a polynomial. Don't worry, this is integral is a polynomial. Means easy to do. After we get u and the back substitute, we get what is the derivative, okay, for the variable x. Okay, so I hope you get this idea, and then I will going to complete the example to show you how to do step by step, no matter which way. Okay, look at this, and we look at this. Okay, so based on the general idea, okay, I put it here so you can see. Find which power is odd. So of course cosine, right? This is odd. Remember, later we need to do substitution for sine, so make it ready. So separate this, separate 1 cosine to make this together, and then what do we get? After we separate, so these are directly put here, okay, equals sine the fourth power cosine also fourth times 1 cosine x dx. Okay, before we're going to do substitution, we need to substitute the sine, right? Substitute the sine. This is a sine, this is another sine. Remember, what do we do? Pythagorean, make it these two sine, right? Okay, I put the Pythagorean here. Which Pythagorean you know is a cosine square equals 1 minus sine square. We can make a cosine to sine, and then after we make it, now we can see, okay, what this we get. This is going to sine the fourth power. So this is going to this 1 minus sine, right? 1 minus sine square, and then make a square again. Cosine square goes to cosine the fourth, and then times cosine x dx. Now is ready for substitution. You know the substitution. This is order, substitute another, the opposite. Okay, substitute the sine, and then you get it. What is du is a cosine x dx. See what is this? We definitely have it. This is du, right? Good, that's already du. How about this? This u raised to the fourth. What about this? 1 minus u square. Okay, I mean to put all together is what we said in the previous one is a polynomial of u. Now easy. All we need to do is just plug into the polynomial. This is u fourth 1 minus u square, and du. See how easy. Separate, right? This is the perfect square separator, and then do distributive. What do you get? I wrote here. You will get a u raised to the fourth minus 2u6 plus u raised to the eighth. Okay, this is the integrand. Okay, and this du. So again, each one is a power. Of course, we will have a power as an antiderivative. So the first power is 1 over 5 u raised to the fifth minus 2 raised to 2 over 7, right? U raised to 7. This is 1 over 9 u raised to the 9. Raised to the 9th power, right? Don't miss plus c. Don't stop it here. You know, u is not we need x. We have to back substitute. After we back, what do we get? We get this. Sorry, so you cannot see now. Okay, this is what we need to back, right? So back u is sine x. So we have sine raised to the 5th power minus 7th power plus 1/9 sine raised to the 9th power and plus c. See, even this looks complicated, but the basic step is not so complicated. Okay, we look at one more, another example. It's very similar. I hope you already get the idea. All we need to do, so the first I make here. So the first we look at which is odd. Okay, so this is odd, right? So we find this is odd. If this is odd later, what type of substitution for cosine? Okay, make it ready. So we need to separate this first. We need to separate sine. Okay, and then what do we make? I'll put that to here. So we will make this. The second power left, and the cosine 6th power times sine x dx. Okay, sine x dx is d cosine. That's why we will make this type. Okay, now before we do substitution, we substitute the cosine, right? So this is already u, but this is not Pythagorean. Remember? So Pythagorean. This is Pythagorean. Sine square equals 1 minus cosine square, right? Okay. And then we put in, what do we have? So this is 1 minus cosine square times cosine raised to the 6 times sine x and the dx. Okay, now it's ready, right? Okay, it's because this is d cosine, this everything is cosine, so we can do substitute. U equals cosine x. Okay, if we have this, what is du equals negative sine x dx? See what is? We do have negative du. What's this? And this is a polynomial of u, right? Okay, so now it's the same as before. We just do basic calculation. So I put it there. So this is what is 1 minus u square and u6 times negative 1. Okay, I use negative 1 times du. This looks better. So now look at the integrand is a polynomial. Okay, I'm going to make a polynomial. If you expand do distribute, what do we get? Get u raised to the 8th power minus u raised to the 6th power and the du. See, that's how easy. Okay, and what is that? The power, right? 9 minus 1/7 u raised to the 7. Don't miss plus c. Also don't miss back substitute. Okay, back substitute, what do we have? So 1/9. U is a cosine, so this time is a cosine raised to the 9th power minus 1/7 raised cosine, so this is 9. Okay. 7th power and plus c. That's the answer for these questions. Okay, one more. So we look at it. These two examples are very similar, right? All this is the basic steps we need. All we need is just like that. So one more, we look at this. We look at the integrand, the power. The power is 4. It's not odd. So I'll make this. This is not odd, it's even. How about another power for cosine? Okay, we did not see, means the power is 0. See, look at, because what? This is 1, right? The powers still even. Let's go to the third case. Okay, both of the power are even. What do we need to do? Remember the suggestion, the strategy is reduce the power, right? We need to do power reducing. Okay, all I say is reduce the power. Okay, how do you reduce the power? We use power reducing, or we call it half angle, right? So I reduce this power here. Okay, so first I'm going to reduce the power 4. How do you reduce? Power reducing, we need a basic power second, so we make this power goes to the fourth, right? And then we have a power reducing or the half angle. If I say it's a half angle, okay. The half angle formula you learned from trigonometry here. What is that formula? Okay, the formula is here. Is sine theta square. We can reduce the power as 1 minus cosine double angle, right? This power goes to 1. Decrease the power, you have to increase the, you have to double the angle. So this one we just plug in. So what do we have? We will have this 1. So it is right. 1 minus cosine double this angle 2x. That we are use the general formula, use another angle theta. Okay, so here is x, is not theta. Okay, but the square. You see, this is power, the perfect power. I can going to simplify by expanded the power. So it's 1/4, and then what do you have? 1 minus cosine. You know what the perfect power, right? The perfect square. 2x plus cosine square 2x. Okay, look at it. This is easy, right? This is the constant. The antiderivative we know. This cosine antiderivative we know is sine. How about this? We don't know. It's still power, but we can use the same strategy. This power we can reduce one more time. Okay, we still can use the half angle to reduce the power. Another half angle for cosine is this. It is very similar with that, but it's 1 plus. Okay, this is a very famous formula in trigonometry. Okay, if you remember, did the formula. Wait. So plug this in, see what do we get. What do we get? It is so it's 1/4. 1 minus 2 times cosine 2x. Okay, this 2x. And then plus, so that's I plug that in. So it is fraction. So 1 plus cosine, and this is double angle. So double cos 2x, which is 4x. Have you get? Okay. Now I just simplify a little bit the compound like term. Okay. What do we have? Is 3/2 minus 2 cosine at 2x plus 1/2 cosine at 4x. That everything together. You see, so each term is easy to find at the end of the value. So it means what? Now it's ready for the questions. So we have this. The original question 0 to pi over 2. Okay, let's get a little bit up. Can you see? That's the original question. Okay. Now we know equals what? Okay, 0 pi over 2. Remember we deal with this, right? So we already reduced the power from 4 to the power 1. This power is 0. Okay, I plug this in to the integrand. So now it's 1/4 times 2 minus 2 cosine 2x plus, I just copy, okay? So dx, and now fundamental, right? We can get the answer. This factor out 1/4, and what the antiderivative for this 2 times x. What this minus sine 2x. You can imagine why the coefficient disappear, because this is chain rule. Take a divisor, you can make it 2. Okay, it's the same for that. What is the coefficient? 1/8 sine 4x. Okay, see. So from 0 to pi over 2. Then now these two special angle plug in is special angle. You know, you simplify. What do you get? We get this, and that's the answer. Yeah, that's all. Thank you.